I just have to be humble and just learn.
Right. Okay. So we'll keep that in mind. What I was trying to ask is that, is there any questions that we need to deal with before we start our session? Like any questions regarding the introduction that I just went through for modules? Any questions on that, or should I just begin?
You can begin.
You can begin.
Right, thank you. So I'll just move forward now. So, introduction to control systems training. Now, in this image, you can see that there are two types of industry images. On one side, I can see the petrochemical plant with its very identifiable fractional distillation columns, and on the other picture, I can see the power plant with its, with its boilers and everything. So I can, if anybody has any previous experience working with any of these, they can immediately see at the images and identify that which is going to be a power plant and which is going to be a petrochemical plant. So now if we move to the next screen, we can see that there is a food processing industry, and then we can see an example of an assembling industry. So why there, what we are trying to show by these two slides is that there are, although both the slides are actually showing manufacturing process, but there are two different types of process industries, right? So we'll move forward and learn about them. Anybody will have any question about this?
No.
All right. So the two industries that I was talking about are discrete manufacturing and process manufacturing, right? So the first image that we saw was a process manufacturing example. Extracting oil and gas from crude oil is a process. You follow steps in sequence and then you obtain your process variable. So it's a process that is used in power plant and oil and gas. That is why they are an example of process manufacturing. While discrete manufacturing is an industry in which you are producing finished product that are being assembled together by putting identifiable parts together to form your final finished product. Let's say, for example, let me move back. You can see the example of the automobile industry, or you can see aircraft being assembled here. So what is happening here is you are manufacturing finished products that are distinct items. A model of an aircraft, let's say Airbus 737, or a car. They are identifiable distinct items, right?
Right.
Right? I'm sorry, I missed that. Am I audible there?
Oh, yes, sir, go.
Right. So what I want to say by this is that these items are distinct items which are easily identifiable and they can be counted. So what is happening is discrete products are being assembled in discrete manufacturing. Products are assembled using distinct items capable of being easily counted, touched, or seen. That what it means is that there are several parts that are assembled together to create your final finished product. And this final finished product is very unique, very identifiable in their own way. You can identify a car by its model, right? Although there will be several cars of that model, but that will have its own identity. And at the end of its life cycle, any finished product of discrete manufacturing, at the end of its life cycle, you can break it down and strip it for parts and reuse them later on, either in any further manufacturing or to manufacture something else, right? So discrete manufacture is an industry term for the manufacturing of finished products that are distinct items capable of being easily counted, touched, or seen. In theory, a discrete product can be broken down at the end of its life cycle. So its basic components can be recycled. An automobile is a product of discrete manufacturing. So this is the same example that I just used, right? Then there is process manufacturing. In process, you're actually trying to follow a recipe or a formula. You're following some steps. You are subjecting your raw material, your input material to some kind of steps, some recipe. You are heating it, cooling it, you're crystallizing it to obtain your final finished product. Unlike discrete manufacturing, at the end of its life cycle, the finished product life cycle, you cannot break it down to obtain the raw material again, right? You can't break it down to and use it for recycling some of its components. Like if at the end of the life cycle of an automobile, at the end of the life cycle of an automobile, you can break it down, strip it down for parts, and reuse parts in further manufacturing of some other product. But let's say if you take an example of process industry, you are producing, let's say, sugar from sugarcane. You can't break down sugar again. Once you have obtained sugar from that sugarcane after following the process, you can't break down sugar to obtain sugarcane again, right? So in process manufacturing, the product is created by using a formula or recipe to refine raw ingredients, and the final product cannot be broken down to its basic components at the end. So process manufacturing industries include examples such as chemicals, food and beverage, gasoline, paint, pharmaceutical, fertilizers, so power plants. Any questions about these?
No.
No.
Right.
No.
Right. So now we get to some pointers about discrete manufacturing, right? So discrete manufacturing is all about assembling things and making things that are exact, which is to say that if you're manufacturing something, right? Let's say you're building an automobile, you're building a bike, or maybe a car, or maybe a pickup truck. The thing is that you are putting together some components, some parts to create a finished product, but although you're making several of those, but they're all going to be exact. If, let's say, it's a model of a car, then that model is always going to be exactly similar, right?
Yes, sir.
Right. So the products are typically manufactured in individually defined lots, right? So let's say there is this one manufacturer that is producing a car as well, a pickup truck as well, maybe some other vehicle as well. So they are going to do it in defined lots. They will have this production line for that product, maybe another production line for their trucks, maybe another production line for something else, right? The sequence of work centers through production varying for each one of these. So although you have to follow a sequence, but the basic outline will remain same, but there may be some separate steps that will, differentiate the whole lines from them. Thus, in discrete manufacturing, the product is made by sequential steps made in the same process or by the same craftsman. So, although there will be a difference in manufacturing of these defined lots, like if you are building product A and you are building product B, although there will be a variation in the steps of both, but as long as you're going to build product A, you'll follow the same process in the same way, right? Discrete manufacturing based on the production orders and product change frequently from order to order. So we can say that some items are more desirable in some seasons while some are not. You can say Some items are much more in summers rather than in winters. In winters, it may reverse. The products that were not in demand in summers are now in demand. So that way, your production is going to be based on lots of factors, the types of orders that you are receiving in the region in which you are operating or producing. So discrete manufacturers are making a finished good that may have screws, nuts, handles, etc. that can be taken apart and used on something else if need be. So what it means is that, as I said earlier, you have smaller parts that you put together to create a final finished product. So you can take them apart or you can use the same thing on something else as well. Manufacturers produce different models of cars, but sometimes if they have 2 or 3 types of sedans, they may have the same type of handle, the same type of door handle, right? So you can use the parts either by taking them apart from a finished product or entirely on a different product line. So in discrete manufacturing, the manufacturing floor works on shop orders to build something. The individual products are easily identifiable. This I have been outlining since the beginning, that the products are identifiable. A brand and a model are easily identifiable, right? So any questions regarding these points?
No.
Nope.
So let me move forward. Now we come to the few points on process manufacturing. So process manufacturing is when you have a product that requires a set of processes to be finished. Each process in turn has certain needs. So you have to follow a few steps. You have to follow those processes, and at the end of each step, you obtain some product, which you then further subject to another process and keep on refining until you get your final finished product that you were trying to obtain. Thus, each process is separated from the other while planning and setting the manufacturing requirements to ensure that the individual processes are better controlled and maintained if they are dealt separately. Process manufacturers build something that cannot be taken apart. Technically, you can take the mix out of the container and reuse the container, but you can't take the ingredients out of the finished good. So that means that the same example we can use, like you can't break down sugar to obtain sugar cane, or you can't break down your energy that you produced, your power, to break down and obtain the gas or the coal that you use to produce it, right? So this makes process manufacturers process, recipe, or formula based, right? In process manufacturing, you can't tell the difference between one product and another. So what they mean by this is, if we go to the point of discrete process, the finished product that you are building is clearly identifiable. Yes? Yes?
Makes sense.
Yes.
Right. So you can identify the model and the brand of the car, right? You can clearly separate them, that this is brand A, model X, this is brand B, model Y, right? But in process manufacturing, you can't do that. You can't say that this gasoline that I'm getting is either from manufacturer A or B. You can't just look at the container and tell whose gas is it going to be, right? So any questions regarding process manufacturing points?
No.
Nope.
Anyone?
Nope. Nope.
Right. So let's move forward then. So this slide is a slide example of discrete manufacturing, a car assembling process. So what we can see here are a few steps that once that are executed in a sequence to assemble a whole automobile, right? So a few steps may be like, somewhere you may be doing one step before the other. So it's a generic process. It doesn't have to be exactly similar, but the example is put in place to explain that in discrete manufacturing you will have your steps outlined very clearly, and you will be executing them step by step, putting together different smaller parts to create your whole final finished product, right? So we can see that first there is a chassis assembly. So you're putting together your chassis, then your axle entire assembly is attached to it. Then your engine assembly is put in your chassis. Your gearbox assembly is then attached to it. So now you have a working axle, engine, and gearbox. Your transmission is ready, right? Then you put in your radiator assembly. Then seats are assembled. Once you have done these steps, you put in together your electrical wirings and electrical assemblies, your ECUs, your sensors, etc. Then the main body assembly is being done. Main body, you say that you put in your boot, you put in your bonnet. Then windshield assembly and other glass are put in. Later on, they have used the example of wiper assembly, door assembly. Then the final finishing trim assembly, you put in together your door trims and other small plastic items. Then once all this has been put together, you subject the vehicle for a final inspection, and if it passes the inspection, then you get your finished car, right? Anybody who has seen this process?
No.
No.
Right. Well, you can use this as a generic example of this now. Right. So any questions based on this?
No.
No.
Okay.
So far, so good.
What? I'm sorry. Someone said something.
No questions.
Right. So
No questions.
Let me move forward, right? Okay. So this now is an example of a process industry. The process manufacturing in oil and gas refinery. I am sure that most of us can recognize the image there. It's a fractional distillation column. How many of us actually remember this?
Me? I do.
No, but
Right? So most of us can actually recollect that this is a fractional distillation column. We must have studied it at one point or the other in our educational background. So what we can see here, it's a column, right? And as the name suggests, fractional distillation column. So it's a distillation column in which your crude oil is being input from one side, right? And it is going to be distilled to obtain different products out of the raw material, that is your crude oil. So what is happening here is, you guys can see my mouse pointer, yes?
Yep.
Right. So you can see that there is this here is your crude oil inlet. This is your furnace where you're actually, when the crude oil is flowing through it, you're heating it, right? So once this heated crude oil flows into your fractional distillation column. Now this fractional distillation column will have different temperature ranges at different levels, right? Right?
Right.
Yes.
Yes, sir.
Yeah, guys, please interrupt me if there is something that you want me to repeat, or if there's something that you want more explanation of, or is not clear, right? So once this heated,
I
right.
think at this level, we don't ask a lot of questions because it's something like a review that we already did.
Yeah.
So it's still basic, so it's not really.
I know.
At least for me.
Right, I know. But to consider the whole group, we don't know that maybe there may be someone who may have a question. So as a duty, I have to ask that if somebody has a question, right? So we'll see.
Yes, sir.
Right. So when the heated crude oil enters this fractional distillation column, right? Because of the heat, most of the crude oil is then converted to vapors and all. So it rises above in the fractional distillation column, and these these fractional distillation column, these fractions, all of them have a different temperature range that is being maintained there. So while the vapor or the oil rises there, you can obtain different products at their own different temperature ranges. Although it's not such a simple process, it does not only follow the only steps that I'm saying. There is a lot of other factors there as well. There's a whole lot of chemistry going on. You're putting reagents and all. But to understand it at this process, yes. So what is happening here is fractions increasing in density and boiling point are settling down at the bottom, right? But fraction decreasing in density and boiling point, the vapors, they are rising above, right? So you can, now that you have different temperature zones, they are going to cool off at different temperature zones and turn into your process variable, your liquid. So from there you're or in a gas form, so there you obtain them. So at the top you have C1 to C4, which is your gas. So you use this for liquefied petroleum gas. This is obtained at, let's say, roughly 20 degrees centigrade. Then from C5 to C9, you're obtaining naphtha, which you are going to you're going to take ahead into a naphtha cracking unit, and you're going to use it to create your fertilizers and chemicals. This is obtained at 70 degrees centigrade. Now these are rough estimates, right? Then C5 to C10 is your petrol or gasoline. So this is gas for vehicles. This is at 120 degrees centigrade. C10 to C16 is your kerosene or your paraffin oil. This is your air grade fuel. So jet fuel, paraffin, wax, lighting and heating oil. This is obtained at 170 degrees centigrade. C14 to C20, these are your diesel oils. So you obtain them for heavy diesel engines like trains and all. So this you get at 270 degrees centigrade roughly. C20 to C50 is your lubricating oil. You get your lubricating oils, waxes, polishes. Basically, the example would be engine oils or wax for your cars, right? So the raw material, the major component is obtained from this C20 to C50. Then C20 to C70 is your fuel oil. This is for very, very big diesel engines, like you have what you have in your factories or what you have in your steamliners, your big ships. 600 degrees centigrade. And C70 is your residue. You get bitumen for roads, you get coke. So if you have a delayed coker unit, you can refine it more and obtain the coke directly that is being used for many, many more purposes. Any questions regarding to this slide?
No.
No.
Right. Right. So when we look at both the above industries, it becomes clear that a lot of complex processes have to be done with accuracy and precision in obtaining the finished products. Yes. So it is going to be a labor-intensive task if it's manually operated, right? Also, the risk when manual labor are in the vicinity area of production also increases. So the risk for manual labor also rises in case of process industry due to usage of chemicals and conditions of parameters which are controlled. Although, which is to say that it is not that discrete industries do not pose risk there as well. There you have robots that are welding stuff. You have robots that are cutting. There are shredders. So a chance of an injury is just as much present as there would be in a process industry. So due to some of the above mentioned factors and other such factors, industries have long been looking for alternative techniques wherein the process can be done accurately, resulting in better quality of products as well as providing safe work environment. So what the idea is that you want to keep your human manual labor away and out of harm's way while producing more product of better quality, right? So this requirement actually is what led to the replacement of humans with various control equipments to control the process. This is called as industrial automation, right? So I hope everyone would agree with the points that we have. and I don't think there must be a question on this, but if there is, you can please ask. Right, so I'm moving forward, right? Right, so industrial automation. So this word is made, this is made up of two words, right? Industry and automation. Now industry is something that is a group of manufacturers. Any group of manufacturing producing the same type of product, you can align them as that industry, like automobile industry, right? Oil and gas industry, fertilizers and chemical industry, right? Power industry, energy sector. So an industry is a group of manufacturers or businesses that produce a particular kind of good or service, right? Now the second word, automation. So the word automation is derived from the Greek words auto and matos, where auto means self, while matos means moving, which means that anything that is self-operating, self-dictating, or a mechanism that is moving by itself can be termed as an automatic and will have the domain of automation. Industrial automation can be defined as the use of technologies and automatic control devices that result the automatic operation and control of industrial processes without significant human intervention and achieving superior performance than manual control. Right?
Yes.
Right. Any questions on this? Although I know that there won't be much. Right. So now we come to an actual example of it. So to understand the above derivation better, let us look into an example of a process. So in most of the industries, there is a requirement of hot water for various purposes. In our case, we will look at supply of water to a number of cleaning stations where the water temperature needs to be kept constant in spite of the demand, right? So for the solution of this, we have put in together a process which you can see on screen. Now, is there anyone who can just look at the image and try to explain what is happening here?
Oh, I can try.
Right.
The cold water come in, where you say in, and there's a heater element. I don't know if it's a heat exchanger or what, boiler, but there's a heat element who heat the water before it goes to the tank. And we have a thermometer, which is basically a control element. We have a valve. Also, the hot water, when it's in the tank, there's a steam will go out through the valve and in the, I don't know, in the process. So the valve is there to be open or shut. It can be shut manually because I see the hand of a man.
Yeah.
So basically, for me, that's the understanding. Basically, the end process is to produce steam that is used maybe to turn, I don't know, maybe engine or to do anything. So
yes,
that's my understanding.
Let me explain that now. So by the diagram, we can see that there is a heat exchanger that is being put in place, right? This is your heat exchanger where you have a cold water inlet and you have a hot water outlet. This being your thermometer that is being observed by a manual operator. This is your heat exchanging variable, right? These are your steam line pipes. So they are carrying hot steam and this is carrying your inlet water. So this here is your heat exchange happening and you're heating the water by the steam flowing in the pipes, right? So when your temperature, so you want hot water at the same temperature, right? So this operator here will be manually observing this thermometer, right? To see that the temperature remains in the ranges that are approved for it, right? The hot water temperature ranges. And whenever the temperature starts to fall below the range, what this manual operator will do is it will open this valve and let more steam flow in, so that the water heats up and remains in the range that we want it to be. Then whenever the temperature increases beyond, it's going beyond the range of where we want the temperature to be, then this manual operator, after observing the range in thermometer, will close down this valve and reduce the flow of steam to heat exchanger to keep the water cooler and in the range that we want it to be, right? Let's see the process. Steam and cold water are fed into heat exchanger, where heat from the steam is being used to bring the cold water to the required working temperature. A thermometer is used to measure the temperature of the water from the process or exchange. Now, how would you maintain the water at the defined temperature irrespective of the changes in the demand of water at outlet? I just explained how we are going to do that, yes?
Right.
Yes.
Right. So if the temperature has to be maintained, there should be a constant monitoring of the thermometer and adjustment of the steam flow, which is what our manual operator is doing there. So this can be done by two ways. The manual one, as we saw in the image earlier, or the automated control. Now let me move forward and show you the automated control. Now let's just first read about the manual control. So in manual control, the temperature is observed by operator who adjusts the flow of steam into heat exchanger to keep the water flowing from the heat exchanger at constant set temperature, right? We just discussed that, right? But in automatic control, you take out the manual operator from the equation. You put in the output variable now is being sensed by the amplitude of the output parameter and is compared to desired or set level, which we sometimes call a set point. And an error signal or a reference signal is sent to the controller, and a corrective signal is then sent by the controller back to keep it at the desired level. So what basically it means is that now in automatic control, you're going to put in a controller there, you're going to put a sensor there. Now this sensor, your temperature sensor, will constantly be monitoring the temperature of your hot water coming out, right? So whenever this hot water temperature falls below a range, now the sensor is sending the temperature constantly to your controller as an input, right? So when the temperature goes below range, this input will then be, the controller will receive this input and then evaluate it as per the logic that is written there. So if it is below the range that is acceptable, this will mean that the controller will take this as an error signal and then will take a corrective action upon it, which would be that if the temperature is lower than what we want, then it will open the steam inlet, and if it is more, then it will close the steam inlet, so further increasing or decreasing the heat exchange capability of our heat exchanger and thus maintaining the temperature of the water. So in our case, steam, a temperature sensor, is attached to the outlet pipe. It senses the temperature of the water flowing. As the demand for hot water increases or decreases, a change in the water temperature is sensed and converted to an electrical signal, amplified and sent to a controller that evaluates the signal and sends a correction signal to an actuator. Actuator here, steam inlet valve, right? The actuator adjusts the flow of steam to the heat exchanger to keep the temperature of the water at its predetermined value. So this is what I just explained, but in a simpler term, right? Any questions?
No.
Right. So we can see that the image here now. So this is how the manual control to automated control changes occur in the industry. Thermometer is replaced by sensor, which produces electrical signal. The human response is now being provided by a controller. So you can see now we have replaced it by a controller which is receiving an input from the sensor and providing an output to your actuator of the valve, right? So this is how the manual, we already have read this. We move forward. Now we come to the point of advantages. Now, what are the advantages of industrial automation, right? Now, before actually we move into this, I would like to have a discussion. I would like to know from you guys what you think are the advantages of industrial automation.
Efficiency.
Right? I'm sorry?
Efficiency?
Right, yes. Would you be able to explain that a bit as well? Like, what do you think? Why do you think it's an advantage? Why do you think that this is more efficient?
Well, I think it's more efficient because I believe that the ability through automation, you'd have the ability to duplicate a quality process faster, and yeah, I just think you'd be able to get
right,
you know,
yes, I get it. Right, very right. Yes. Anybody else? Any other advantage?
Well, we can also say the efficiency is because the control of the valve is direct proportion to the temperature. When you're using a person, it's like guesswork. I mean, they don't know how much to open or how much to close the valve.
Okay. That we can say is partially correct. Most of the time, the operator work is not going to be guesswork. See, there would be a thermometer, and the person ideally is supposed to monitor it constantly. Of course, it is true. What you want to infer is that most of the times the human error would be there. Maybe they were looking at the thermometer, maybe they were not. Maybe they were lazy, maybe they were distracted. So that of course is there, and that is what we can say is our next advantage. That you know, the advantage.
Even if
right.
Go ahead.
What? Should I?
Go ahead. Continue.
Yeah. So the advantage is the consistency, right?
Yeah. I can add accuracy.
Yeah, accuracy and consistency. So your controllers do not get tired, right? They do not go through with emotional and physical tiredness or issues. They do not get bored. They do not need motivation like humans do, and they can always produce exact same product, right? So consistency is what is also a very important thing here, that regardless of how much a human labor would try, it is very rare that they will be able to produce the exact two products, right? There always is going to be some small difference in their products, right? If you, let's say, if you're manufacturing furniture, you're building some chair or a table, you can try to build them both same, but there is always the chance that there will be some error in their dimensions, even if of a few millimeters, but it mostly is there, right? But with machines, you can expect, with automated control, you can expect that all the products are going to be of the exact same specs, exact same look, feel, design. Everything is going to be similar, right?
Yes.
Anybody else would like to guess any other advantage of?
It's cheaper.
Yeah, it's cheaper. It's cheaper because it increases your production values in manifolds. Right? With human labor, you have to take care that, you know, they get tired. There are shifts, or there is a few hours only that they can work. But the machines can go on tirelessly for hours and hours at a stretch, right? So inherently, they increase your production. The machine does not need lunch breaks, tea breaks, right? So inherently your production value is increasing. You're producing much more than you were doing earlier. That in turn means much more sales. And compared to that, yes, the systems is much more cheaper.
Also, energy reduction.
What?
We are able to save some energy, whether it's human energy or other type of energy.
Right. I'm sorry about that. Right. So now we'll try to go through with the advantages. So advantages of industrial automation. The following are seen as the advantages when industry is automated. High productivity. So we just discussed this. Automation of factory or manufacturing or process plant improves production rate through better control of production. With manual control of the production line, there is always a requirement to have some downtime to ensure effective working of workforce, right? Whereas the automated control systems will be able to work for long hours without compromising on accuracy. So hence the increased productivity and efficiency per hour of labor input. We just discussed this, yes? Then there is the high quality. The automation system performs operations with greater conformity and uniformity to the quality specifications once it is designed and programmed, right? Thus, by using the automation system, industrial processes are controlled and monitored at all stages in order to produce a qualitative end product. So this again is the point that I was trying to iterate, that it is going to produce exactly the same type of product, right? None of us would want to pay for a product if my product looks different than somebody else's product while I'm paying the same money, right? They may be getting that table and the table's finish would be much more better. The color would be much more richer, while I may not have the same kind of look and feel to it. But we're both paying the same money. Yes? So nobody would like that. So you have to maintain the consistency in product quality. Then there is the high flexibility. So when making changes or upgrading tasks, humans require training, right? But with machines, robots, they can be programmed to do any task, right? So let's say you had a robot that was doing your spot welding jobs earlier, but now you wanted to paint the vehicle. So you can very easily download a new program to that robot and now use the same robot which you were using earlier for spot welding. With the same efficiency now, you can use it for painting, right? In your paint shop. So the robot does not need any training. The robot did not needed any kind of specific classes or something for it. All it needed was you took a program and you downloaded it. Earlier it was running some other program with its instructions. Now it's running another program with its instructions, right? Then high information accuracy. The automated systems are enabled with easy data collection techniques, which allow us to collect key production information, improve data accuracy, and reduce data collection costs. This provides with a pack to make the right decisions, enabling and reducing waste and improving processes. Can anybody give me an example of this?
With the SCADA, maybe when for the PIG, let us put just it small because I'm trying to go far. Like maybe if the robot we get the information, maybe we can try to. I don't know how to put it simple. Like with the data we get maybe from. Let us take the example that you just got from the heat or the hot water with the coming of the cooling water and the two sensors. The sensor can give us some feedback, and based on that, we can decide to increase or decrease the steam the steam rate. I don't know how to put it together, but anyway, based on the information we get from the sensor who are very accurate, we can decide to put more information on the controller to maybe decrease or increase the type of the steam we get from. And I think that's what I can say.
Right. Anybody else would like a go at it? Try to give another example.
You could use the information for like predictive or preemptive maintenance.
Right. Yes. Another example that I would like to put in would be of trends and logs, right? For trends and logs, if you do not have an industrial automation system, you need a person who's actually going to do your manual entries. If you want them every half an hour, or you want them at an hour, or maybe at every shift, one person has to do all those entries manually, right? So
yes,
so that would be a laborious task. Then whatever manual data logs that they are creating, they would have to be, they would be processed further to generate reports now. So again, you will need that data transferred from your logs to another software utility, which is going to create your graphs, or maybe Microsoft Excel or something, where you're going to create the plots for it. And only then will you be able to analyze them, right? But with industrial automation systems, you get your data logs logged automatically. You can create data logs with it. You can create your trends, and you can monitor them online, live, or historical data on them, right?
Yes,
so that in itself provides you with very consolidated information, which absolutely helps you in taking the right decisions for your process.
That's true.
Right. So high safety. Work environment is made safer by transferring the work from an on-location role in the process to the supervising role. So the automated machines designed to work in the hazardous environment and other extreme environments, industrial automation makes the production line safe for the employees by deploying robots to handle hazardous conditions. So if there is some kind of, let's say, difficult assembly process where there may be, the temperature may be higher, where they may be, let's say you have your process variable, there is an aerosol spray, let's say in a paint shop. Since you got robots to paint your vehicle, you don't need to send your manual labor to paint them there, and they don't need to breathe in the harmful chemicals now. Similarly, for a welding, shredding, cutting job, if you got robots for it, you do not need human labor operating these tools, and the chance of them getting hurt reduces substantially. Yes?
Yes.
Right.
Anybody would like to, give an example where they may have, witnessed something where they may have observed that an industrial automation system was able to prevent some kind of equipment damage or injury?
Or like an example is maybe those oil steel manufacturers who get the old car or the steel and they burn it in the burner or boiler, and the temperature is very high. If it's a human being who goes there to get the temperature, that may affect his health. But when we put like a thermocouple or there is no problem. So I think that's safe.
Okay. Right. Yes. Right. So let's move forward. Now we come to the layers of automation, right? So the industrial automation systems, they are being implemented in layers, right? So there are different layers which are actually handling. There are different different operations. They have their work very clearly lined out for them, and they are basically executing that task only. It's just when they interface together with each other, that is when you get a complete industrial automation or a industrial automation system or a control system, right? So industrial automation can be complex in nature. They have large number of devices working in synchronization with automation technologies. The figure below describes the hierarchical arrangement of an automation system. So you can see there are 4 levels here. So there is one field level, then there is your control level, then there is supervising and production control level, and then there is your information level. So let's just talk about the different levels. Would anyone have an explanation where they may have seen in such a way?
Oh yes, sir. Like maybe when I was working with plane, at the field level you have your field device, like your pressure, temperature sensor. At the control level you have your RTU, like the PLC.
Yes.
And the supervisor and control level you have SCADA. And the information level you can have the decision maker.
Right.
Like the computer with the decision maker.
Okay.
The software.
You mean the controller?
The information level means that you get those data, the trend and all that coming from the SCADA and all that, and you make the decision. So I start at the field level with the field device like pressure, sensor, temperature, and motor, and right. I go to the control level with the PLC, and the supervisor level with the SCADA in the control center. Means that the PLC is most of the time at the remote terminal unit, like at the outside on the field. But when you get the information, you send it to the SCADA in the control center. When those people from the control center got the information now, they may send it back to the decision maker, like the manager or the supervisor or the engineer, or maybe you have a headquarters somewhere, they may send those information at the headquarters for them to take appropriate decision in the information level.
Yes,
and you can also keep the data. So that's what I think.
Right. So let me put that in my words as well. What you have explained is very correct. So we have 4 different levels. You have field level, then you have control level, then there is the supervisory and production control level, and then there is the information level. So your field level is where you have your production field, where your field instruments are going to be put in. Your motors, your valves, relays, sensor, barcode sensors, your temperature transmitters, your big pumps, everything are going to be in your field, right? This is where your actual production is happening. This is where the real action is. So your field instruments are your inputs and output in that field, right? From there, through your signal cables, you're going to receive or you're going to send out information to these field instruments. And this information is being received and being sent out by the controller, which evaluates the inputs that it receives, and based on that takes a decision after following the logic that it has in its memory. See, the controller does not have its own intelligence, right?
Yes, sir.
Right. It's not a device. Yeah. So it's not a device that has artificial intelligence. It cannot take decisions by itself. So it will only follow steps that are written in its logic. Let's say I have written the logic of a controller, and what I wanted was that when, let's say, the temperature rises to this level, I want the valve to close, right? But while writing my logic, I made a small mistake and used a normally closed contact instead of a normally open one. We'll talk about what normally open and closed as well later on, but for now let's just say that I made a small error in my logic. Now the PLC can only follow the logic that I have written there. So although I wanted the valve to close, but if by error I have written my logic so that the valve should open, the PLC will not be able to make a decision on this. If I have written the logic to open the valve, although I wanted it closed, but in my logic I have written so that it will open, then the PLC will open it, right? Yeah.
Right, sir, right.
Right.
Yes.
So that is why the PLC does not have its own intelligence. It follows the logic. So whatever inputs it is going to sense from these field devices, it is going to put them in evaluation with the logic that is written there, and based on that evaluation take necessary actions which will then result in your output commands, which again will go to your field elements and decide the course of action for them. So if I've written my logic correctly, then the valve will close. If I have by mistake written my logic incorrect, then the valve will open, right? So this is your control level. This is applicable for your PLC, your robots, your cutting CNC machines. The other example is also a robot. So this is what field level and control level interface is, right? Now we come to the third layer. The third layer is your supervising and production control level. Basically, this is where you have your SCADA systems, right? Your SCADA systems, your HMIs. So we know what the definition of SCADA is?
Yes.
Anybody would like to tell me that?
Supervisory control and data acquisition.
Right. Supervisory control and data acquisition. That is why we call it SCADA. So as the name suggests, supervisory control and data acquisition. That means that the actual control is being done at control level by the controller. But you have a supervisory control here, right? So,
yes.
You know, continuing my example, let's say I made that mistake in my logic and now the valve is opened instead of closed. But because of the supervisory control, I can witness that happening on my screen. And because I can witness it, I can take preventive and corrective action immediately. I can put my valve from auto to manual mode, and then I can immediately input a overriding manual command by which I can close the valve. Yes?
Yes, sir.
Yes.
Right. Right. So this is where supervisory control comes in. And then there is the data acquisition. So data acquisition, as we just discussed, you have the capability of creating data logs, archiving the production value data into your logs, creating trends out of them, and using this to make meaningful decisions later on, right? So this is where your data acquisition part comes in from SCADA, and this is why this is important. So supervising and production control level is where you have your SCADA and HMI. HMI is human machine interface. So those touch panels, those small LCD, LED touch panels that you have mounted on the machines or on the panels or in the field are the example of your HMI. While a PC based operator station or an engineering station will be the example of a SCADA system, right? So you can have both in one system depending on the kind of access that you want from field or you want it only from control room. But this is all it basically will have. Typically a SCADA system will have an engineering workstation and an operator workstation. Your engineering workstation is where you are going to engineer your project. Project being the graphic, the client, or the runtime, whatever you like to call it. You're going to run. You create that in your engineering environment. So it will have the softwares and the licenses for creating your logic, for creating your SCADA graphic screens and everything. And the operator station is typically where you run runtime and logic and everything, right? Then comes the information level. Now your information level is your server area, where you're going to have your servers which are going to archive this data. Nowadays, a lot of people are opting for this information layer level because there is lots of data coming in from several different systems that may belong to several different manufacturers or OEMs. You may have a PLC system from brand A, then brand B, then brand C, but they're all actually contributing to your production, right? So you want a total value. You want a total production report. So what you do is you integrate the data from all the different control systems, get this to your server where you're going to archive this, use software solutions such as Historian and reporting MES solutions to create meaningful reports out of this data, right? So that you can get a complete overview of how much your production was. You don't have to see that, okay, this system is producing this and this is producing that. Then you have to compare which is better and which is not, which needs improvement, which is okay. So you get a whole complete report out of this when you try to integrate every information into this information level layer, right? Anybody has seen such an example anywhere?
Maybe. Yes.
Of a historian or something somewhere?
I saw it, but I didn't do it. I was not part of it. I saw it anywhere.
Okay, but you have seen it, right?
No, I was not part of it.
Right, no problem. Right, but you have seen it. So anyone else?
Yes, sir. I saw it many times, sir. At Exxon, that's what we was doing also at Plant, but I was not. I was part in the field and the control level, but the supervision and control was done in the control center. We have control center, but I was more in the field.
Okay.
And the historian, I saw it in the office of my manager, but I was not part of it. But at Exxon, we collect data in the control room.
Yes.
I don't know how to do that. I'm still at the entry level, sir.
No, it's okay. I just wanted to know if somebody has seen it already being implemented somewhere. So the others also can understand what the purpose of different levels is?
Yes.
Right? Anybody has any questions regarding any level?
No.
Maybe an example that they want to add? Right. So guys, I would request everyone to participate here, right? That is not to say that I want a forced participation, but what I want is if you do have a question, regardless of how trivial you may think that question is, you're always welcome to ask this, okay? Right, so I'm going to move forward now. Right, so now we understand what the field level is. So this is the lowest level of the automation hierarchy, which includes the field devices like sensors and actuators. The main task of these field devices is to transfer the data of processes and machines to the next higher level for monitoring, analysis, and control, right? Because the field level is providing data to your controller. So there is control itself. The sensors convert the real-time parameters like temperature, pressure, flow, level, etc. into electrical signals. The sensor data is transferred to the controller to monitor and analyze the real-time parameters. So this again is basically the same example. You had the temperature sensor there, which is sensing the hot water temperature and then passing on in form of an electrical signal to your controller. So majorly prevalent signals that you get, these electrical signals are either 4 to 20 milliamperes or 0 to 10 volt DC or 24 volt, right? So depending on the type of sensor it is there, whether it's an analog sensor or a discrete sensor, will decide what type of electrical signal that you're going to receive. So sensors include thermocouple, proximity sensors, RTDs, and flow meters, right? So these are some examples of the field sensors that you can put in. Now a sensor is going to be an input device or an output device?
Input.
Right. So a sensor is always going to be an input device because it is sensing. And what does it do with the sense that it has? It senses and passes on the information to the controller. If it's a RFID scanner, then it's going to keep on scanning for an RFID. And as soon as there is an RFID tag in its vicinity, it will scan it, gather its information, and transfer it to the controller, right? Let's say if it's a barcode scanner, as soon as it's constantly going to be sensing for a barcode. As soon as the box comes in its vicinity and it can scan the barcode on it, it will scan the barcode, gather the information, and pass on the same information to the controller. The controller then evaluates the received information and decides what it has to do, right? So actuator converts the electrical signal from the controllers into mechanical means to control the process. So flow control valves, solenoid valves, pneumatic actuators, relays, your motors and servo motors are examples of actuators. So what is happening here is, once the input sensed signal has been received by the controller and the controller evaluates this signal and makes a decision depending on the logic that whether it has to activate the actuator or deactivate it. Depending on this output signal, now the physical actuator out in the field on your field device is going to operate. So if it's a valve, in this case, the example that we have been using, if the temperature sensed, like the hot water temperature sensed by the temperature sensor, is going above the acceptable range, then in this case, the controller will make a decision to close down the valve. That means the actuator will move to close the valve. While if it was falling below the acceptable range, it will open the steam inlet valve to let more steam come in and let that water be heated more to the temperature where it is in acceptable ranges, right?
Yes, sir.
Yes.
Right.
Yes.
So now we come to the control level. So the control level consists of various automation devices like CNC machines, PLCs, DCS, which acquire the process parameters from various sensors or field devices, right? The automatic controller drives the actuator based on the processed sensor signals and program or control technique. So what they want to try to tell us is that your PLCs are again now sensing the data, receiving inputs from your field devices, and based on those sensed signals and the logic that they have in their memory, they will evaluate and take a decision and transfer their decision as an output command to your output element in the field, and that is how the control is being done. Now, ideally, mostly you will have closed loop control systems in the field, right? Although we are going to discuss closed loop control systems in detail in the further session, but I'd like to mention it here that once this output command is given out, this is being sent to the output field element. The output field element executes this command but the controller needs confirmation for the same too. Let's say the command said that if a push button has been pressed, then a motor should start. Now the push button was pressed, the input signal was sent to the input of the controller. The controller evaluated this input, that this means that I should make this tag high, this input tag. Once it does that, it evaluates that, okay, if this input is high, I am supposed to make this output of this motor high as well. And it made that output high. And then the output sends out the 24 volt to the contactor, then to the MCC panel, and then to your motor, which in turn starts the motor. But how would the PLC find out that the motor has started, right? How will the PLC know? Maybe that it has sent out the output command, but maybe the motor is decoupled in the field. Maybe the motor is burnt out. Maybe there is a power issue with the motor. So how can the PLC be sure that the output command that it has sent out to the motor was acknowledged and executed by it?
By the feedback on the
right, by the feedback. So this is where your loop is closed. Once the equipment executes the output command it receives, the output elements, it sends back a reference signal, which we like to call as feedback of that device. Once this feedback is received at again the input side of the controller, then the loop closes. So this is what we mean when we say by closed loop control system, right?
Yes, sir. Yes, sir.
Right. So programmable logic controllers are the most widely used robust industrial controllers which are capable of delivering automatic control functions based on inputs from sensors and the programs downloaded into the PLC, right?
Yes, sir. Yes, sir.
Yes.
Okay. So DCS is the advanced or more integrated controller used for large process industries. Basically, DCS is your distributed control systems. So in simpler terms, although we will be discussing them, both the PLC systems and the DCS systems in detail in the coming sessions, but in simpler terms, to satiate the curiosity, you can say a DCS is lots of PLC systems integrated together, right? Mostly the DCS system is being implemented as server-client architecture. Right. So any questions on what we just went through?
No. Yes, sir. For the DCS, which one you focus on? Delta V with Rosemore, Emerson, or ABB, or which type? Because they told me that sometimes because the DCS mostly is made by only one vendor and who control all the process and it's more dense. Or some are different, like Honeywell or Delta V. I don't know. For me, the focus, I want to learn more about the DCS and how they integrate and interface, how to program it, and basically.
Well, I'm sure that we will be able to deal with all your queries once we come to the DCS session in the modules. We'll try to cover the maximum that is possible, right? And try to answer that you ask. Okay? Okay?
Yes, sir.
Right, so should I move on? Hi, do you want to say something? Is there someone who is talking to someone else? If you are, then you can please put your mic on mute. Right? So let me just, so should I move forward?
Yes, sir, please.
Yes.
Yep. So, guys, whenever you have some kind of interruption in between, when you have some interruption in between, or you're talking to someone else, or in general as well, when you don't have something to say, I would request you to put your mics on mute so that there isn't any unnecessary disturbance in between.
Hello?
Hello? Hello? Hello?
Yes, sir.
Right. So let me move forward then. So supervising and production control level, right? So in this level, automatic devices and monitoring system facilities, the continuous viewing and supervising of the process, and it provides controlling and intervening functions like HMI as well. So as I told you, this is where you get your SCADA, you get your systems and everything, right? So these systems enable supervising various parameters, setting production targets, historical archiving, setting machine start and shutdown, etc. So mostly DCS will or SCADA systems and HMIs are used in this level, which we already had discussed. Any questions?
No, sir.
Right. So now we come to the information or enterprise level. This is where your information is being gathered by different protocols, and then this is analyzed to create your meaningful reports, which lead into your decision-making process. So this is the topmost level of the industrial automation, which manages the whole automation system. The tasks of this level include production planning, customer and market analysis, orders, sales, productions, everything, right? So it deals more with the commercial activities and less with the technical aspects. So why do you need those reports, right? You want to know how much you're producing, right? Based on that, you will find out that what your costs are. Can you please put the mic on mute if there is some problem there? Right. So it deals with commercial activities more. You want to find out what your costs are. You want to find out how many units you're producing. Based on that, you will want to take a decision on what price you want to sell, what your profit margins are going to be, and how much you need to increase your production or reduce it to keep in line with the demand in the market, right? So industrial communication networks are most prominent in industrial automation systems. They transfer information from one level to other. These are present in all levels of automation system to provide continuous flow of information. The communication networks can vary from one level to the other. The example of some of these networks includes your RS485, which is your serial protocol, then CAN, which is your CAN bus, DeviceNet, Foundation Field Bus, Profibus, and Ethernet. When we come to the networking part, we'll be, understanding more about them later on anyway. So now we come to the hierarchy, or you can say the industrial automation pyramid. So in this hierarchy, there is continuous information flow from high level to low level and vice versa. This can be represented in a graphical way, like a pyramid in which we go up, the information gets aggregated, and while going down, it gets spread out. So you can see that at the base level, you have sensors, your actuators, etc. This is your field. Then unit control is your PLCs, cell control, process control, factory supervisory is basically your SCADA.
Hello?
Here. Yeah.
Hello?
Hello?
Excuse me.
Yeah, tell me.
This is Naveen. I'm one of the students.
Yeah.
Hello?
Tell me. Yeah, please tell me.
Are you recording this class?
I'm sorry, what?
Are you recording this class?
Have we started the class?
No, I'm asking that are you recording the class because I have missed the first part what you said. I need to listen it tomorrow. So are you recording this?
Yeah, I am recording the class.
And you are sending emails to everyone, right? The link?
Yeah, there will be a link in your access profiles.
How could I receive the link? Could you let me know?
What?
How would you send me the link?
Oh no, I won't be sending the link. The link will be uploaded in your profile. You will be contacted. Please tell me your name, and I'll make sure that the team contacts you and updates you about the information, how you can access the link and everything.
Okay, my name is Naveen Kumar.
Naveen Kumar. Okay. So Naveen.
Yeah.
I will make sure the team contacts you and informs you, and I will make sure that the team contacts everyone and briefs them where they can access the videos. After this session is...
First question what you said, I need to reason it one more time.
I understand that, right. So every session I will be recording and I will be downloading and uploading to your students section. You can go in your students section and check it. You will be communicated by the team to explain you how you can do that. Okay.
By the way, how when did you start the class? How long ago?
It's from 8 to 10.
8 to what, right? 8 to 10 Eastern time, right?
Yes.
I just log into the session 15 minutes. That means I missed most of the session, and so that I need to listen one more time.
Can you please get your mic a little away from yourself, because your voice is booming. I'm not able to understand anything that you're saying.
The thing is, I missed most part of the session what you said today.
Yeah.
I need to listen one more time because I just joined the meeting 15 minutes back.
Right. I understand that, Naveen, but we'll take your concerns in the next session if you have any. Okay. So right now, most of the session is over, and I need to get this done now in the time that I have. But whatever your concerns are, you can watch the video and you can either communicate with the team, or you can raise them in the next session, and I'll handle them. Okay.
Okay. Anyway, send me the recording. That's what I'm requesting you for.
Yes. You will have the recording. Don't worry about it.
Right. Thank you so much. Thanks a lot. Okay, you can carry on. Sorry for the interruption.
Thank you. Okay, no problem. Right. So, guys, let me resume this again. So we're talking about the hierarchy, like a pyramid. As you go up, the information is aggregated. It's streamlined. While when you go down, it is spread out to your field devices, which are anyways many in number, right? Let's move forward.
Yes, sir.
Right. So any questions and answers anyone would have about today's session?
Yeah, actually, could I try and give an example of the lists, and then you just tell me if I understand correctly?
Of course. Any examples, any experiences are always welcome.
Okay, yeah, I'd like to just throw it out there and see if I understand this correctly. So on the field, if I was talking about, say, my cell phone, and I was sending a text to somebody, the field level would be the keys where I'm typing in everything. The control level would be it communicating it onto the screen so I can see what I'm typing.
Yeah.
The supervisor control level would be something along the lines of it being sent out after I hit send, and then the information enterprise level would be where the server is that communicates to the other cell phones. Is that more or less accurate?
Right, that is more accurate, but let me just add a few things from my point of view. Now, the keys that you are using to use input, they are your field elements, very rightly said.
Okay.
The processor of the phone that you are using, this is your controller. The ASCII keys that you are pressing, they have to be processed by some processor which will understand the ASCII character code and then transfer it to the Latin word or the alphabet that you want, right?
Right, okay.
So your controller is going to be the processor of the phone. Your SCADA, the example of your supervision layer, would be the screen where you can see that what you're typing, and once you send, then the delivery report that you get, right? You get a confirmation that your message, your text has been delivered, right?
Absolutely.
So the delivery report that you get, that is also part of your supervisory control, because you will be able to supervise what you were writing, right? If there would have been a typo, you would have corrected it, right? That is supervisory control.
Okay.
And data acquisition. So the delivery report is your data acquired, that whatever that you sent out was delivered. And at the end, you have your information, which again, the example would be your delivery report of that.
Right.
So you have a report to show. So if somebody actually confronts you that, this information was not provided to me, you can show them that, I sent you a text and you can see that it was delivered to you. This is the delivery report. This is when it was delivered to you. So the delivery reports act as it is some part of supervisory and some part of your enterprise level as well. Right?
Understood. Thank you very much.
Right. So anybody would like to add anything else to any other type of example, any other questions?
Thank you. I'm really grateful to listen to you, and thank you a lot, sir.
Well, I am grateful to you for being a very patient listener as well, Elaine. Thank you very much.
You're welcome. You're welcome.
Right. So, guys, if you have any further questions, you can please ask. If you have some feedback which you would like to give me so that I can improve, I would be very open to it, and it is always welcome. If I speak too fast, maybe I'm not clear or something, if you want to tell me, you can please be very frank and tell this to me so that I can improve on it.
No, I think you did very good, and I think also you had the opportunity to ask questions when the student was not participating, means that you wanted to be interactive, and that's also good. Also, maybe just also you have part that it was also that you put that student could ask question, and you have image who could spot what you were saying. That I think that the format was great, and I'm grateful for that, sir.
Thank you very much, thank you very much, Elaine. Anybody else would have anything to say?
At this level, everything was very much clear. I hope as we continue will be the same, but at this level, everything was straightforward and clear.
I will try my level best to make sure that as we move forward, I keep the same level of clarity. And as far my commitment is concerned, I can assure you that it will be.
Thank you.
Excellent.
Right. Anybody have any other question or a feedback or something to some points to improve? Maybe. Right. So if there isn't anything, I would like to inform that the next class is going to be on Monday at the same time, right? And after a few classes, let's say almost every week, what we are going to do is we are going to have an assignment which will have a few questions. I won't be burdening you with a lot of them. Don't worry about it. There will be just a few questions testing the fundamentals that we learned in that week so that you're constantly in touch with the course. And they will be either theoretical or maybe multiple choice questions. And also we will be doing an interview-oriented question sessions as well, like where we will try to discuss a few questions that are basically oriented at clearing the interviews, right? That's the point of the course, that you want to learn and then you want to be confident when you go for an interview, right?
Yep.
Yeah, right.
Yeah.
So we'll be doing that almost every week. Every week almost we'll try, depending on what parts we have covered, to have a small assignment with a few questions only and a few questions which are interview oriented so that you guys feel much more confident when you go in for one later on, right? So if you don't have any further questions or anything, I think that is the end of the session for today.
May I ask?
Yeah, please.
Things seem to be changing every now and then. Is this course to be every day of the week or Monday, Wednesday, and Friday, as we are told at the beginning?
No. This course is going to be on Monday, Wednesday, and Friday only. Okay. See, mostly you can expect that there won't be any further changes to the days. But see, sometimes there are technical issues, sometimes there are timing issues, sometimes there very rarely maybe health issues, because of which maybe somebody would want a class rescheduled, right? So in that case, very rarely it happens, Usually, this is not the case. Usually, the classes are kept at the same time on the same day. And I
Hello?
personally try to make sure that this will be done.
Hello?
Hello? Yes?
This is Naveen again.
Right.
Hi. What is the duration of the course? Could you let me know?
Duration of the course is 6 weeks. 6 weeks.
6 weeks, that is every week, Monday, Wednesday, Friday, right? Every week the same timing?
Yes. Every week, Monday, Wednesday, and Friday.
2 hours class, right?
What? 2 hours class. Right. Every 3 times a week, 2 hours class each.
Then when you are going to give the assignment to us?
I believe that we'll try to do it on every Friday. Once we have
Means you have to submit the assignment on Monday, right?
Yeah.
Yeah, okay, sure.
This way you will have time over the weekend. You don't need to worry a lot about the assignments. The questions are not going to be very time consuming.
So if you can, even the questions are tough, that will be good to us because we can prepare that for the interview, right?
Right, yes. So there will be questions which will be testing the fundamental knowledge only, right?
Okay.
Right.
And could you let me know how could we access this software?
How to?
How could we access this software?
Which software we're talking about?
I think you are dealing about PLC software like Siemens, Alhambra, like such kind of software, right?
Yes. So,
then how could we? Because they are not free software, right? We need to purchase them, right?
Of course. So what I'll do is, any of these questions I will be answering in the next session, or I'll make sure that the team communicates through them to you guys on email by highlighting the procedure, what steps you need to follow, where you need to log in and everything, right?
Because if you need to purchase the software, it costs us a lot. We can't bear that. That's why I'm asking this question. Are you getting me?
Yeah, I understand that.
Yeah. You are able to provide access to the software, right? The duration of the course.
I'm sorry. Could whoever is making this noise, please put their mic on mute.
Could I tell you again?
Let me just let yeah. So what I was
you are going to give access to the software. You are going to learn during the duration of the course, right?
Yes, I got the question. See, I would have to check what softwares and what type of access we will be able to provide. So I can only get back to you once I talk to the team. Give me today's time. In the next class, I will have answers to both your questions. Okay?
Okay, by Monday, right?
Yeah, by Monday. Yes.
Okay, Miss. If you have further questions regarding this, could you give me the contact number of the person to ask any further questions regarding this?
I would not be able to do that, but I will make sure that they contact you via email or phone, whichever preferred way they have. But some things are being dealt by the back-end team. Only they can give the answers on that, and only they can contact you on it. I'm not authorized to.
Do you have any contact number or email so that I could get in touch with them in regards to any questions I had?
Everything will be available in your profile. You must have created a student profile, yes?
I haven't yet. That's what the issue is. I just got the link. They sent to me the link. I log into the session using the link, but don't have any. Could you let me know the way to log in and create my student account?
So you will be receiving an account creation email very soon as well.
Okay, so could you let them know that please ask them to send me email.
I got your point, Naveen. I understand it, but for them to get back in touch with you will need some time. I need to communicate. I can't just call them right now and send it to you, right? So give me some time and your concerns before the next class, that is on Monday. I will make sure that your concerns are addressed, right?
Yeah, sure.
Right. Anything else?
Yes, sir. I sent them.
Yeah, tell me.
I sent them an email with my concern, but they didn't reply to me yet.
Okay.
And I just hope that I spoke first with the lady. She asked me to send the concern by email what I did, but I didn't have feedback yet. So I just hope that they will find a way to address it.
I'll speak to them about this. What is your concern, Elaine?
I had two concerns. One was about the certification, because when I have interview with most company, most of the time they are successful, but those companies, when they look for a PLC programmer or a control engineer, control technician, whether it's automation, anybody in the automation level, they want you to be certified, or by, if you say you have DCS, they want you to be certified like a Delta View with Emerson, or they want you to have like some knowledge from GE or some type of certification, whether it's, and they want you to be able to program factory talk or panel view.
Yeah.
Also, I had a concern about the H1B, because on your website you say that you help with the H1B. So I sent that concern in writing, because I had a lot of job opportunity, and with my little experience and my knowledge, I know that I can program, but it will be a good thing if we can get certified or have a good knowledge of those. Having the theoretical knowledge like this, that's good.
So
Everybody can go online and get information. But what differs us? Also, since you said that you have a lot of, you have some, you work with some company like Rosemont and Honeywell, or you have those background. If we can get certified through those vendor, that would be good for the employer, also for the vendor.
I understand your concern, and I'll talk to the team about your email, and I'll make sure that they reply you. Right?
Oh, thank you a lot, sir. Thank you a lot. I'm grateful.
So guys, I think that brings us to the end of the session. If anyone has any further questions, please go ahead. Otherwise, I would like to close the session for today. Right?
Right. Good night.
Thank you a lot, sir. I'm grateful, sir.
Well, I am grateful to all the patient listeners as well. Thank you. Very nice doing this session for you. Let's hope we meet in the next class. Right? So should I close the session now?
Yes, sir. Thank you a lot, sir.
Thank you.
Okay,
Thank
we'll see
you.
you on Monday.
Yeah, see you on Monday.
Hello.
Bye-bye.
Thank you. Thank you, sir.
ఎంతమంది మొత్తం మైండ్లో?
Hi, Ibrahim. You have any questions to ask, or should I just end the call? Right. So I believe that you guys don't have any further questions to ask, so I'm going to end this call now. Thank you very much.